Have you ever had your API or application flooded with a ton of requests? Or have you ever wondered how real time systems actually block abuse? If the answers to those questions is yes, then let's build a rate limiter in approximately 10 minutes. Hello, everyone, and welcome to the channel. If you're new here, I make videos about system design, but with a slight twist. Instead of focusing on the whiteboarding side of things and discussing functional and non functional requirements, I actually focus on the practical aspect of system design. I try to build small components, connect them together, and see how they interact in the real world. Imagine a bucket that can hold up to 10 coins. Each coin in this case represent a real request that your application can handle. Every time a user makes a request, we take out one coin from the bucket. Now here's the cool part. We also refill the bucket with a certain amount of coins at a constant rate, let's say 1 coins per second. Now, if the user waits long enough, they will be able to access our system and the request is successful and there is no problem. But if there are no tokens or coins in this case, then their request is essentially denied. Now, this is the core concept that underpins the token bucket algorithm, which we'll just see in a second. Okay, let us start with a small bucket here. This bucket contains a few tokens, let's say 5 for instance. Now, imagine a user has a web application and they make an API call and also get a response back. So, this is an API call. Now, this is all the boxes that I'm going to be drawing. So, at any given point, the system should be able to figure out how many tokens does the user have, and the user has enough tokens to actually make this API call. Now, every time a user makes a request, we take out one token from here. Now, if there aren't enough tokens, then the API no longer works and you get a 429 response code, which is actually for too many requests. Now, in order to be able to determine the amount of tokens that the user has, we need to do two things. We first need to calculate the number of tokens that we want to refill and then add it to the existing tokens that the user has. So, in order to arrive at this calculation, we need to calculate TTR. So, how do we do that? So, this actually depends on the refill rate and the number of tokens, or sorry, the number of seconds or minutes that have elapsed from the last request time. So let's just write that out. So it will be a multiplication of refill rate and the time that has elapsed. So let's say 5 seconds have elapsed and the refill rate is 5 tokens per second. Then the number of tokens to fill would be 5 times 5, which is 25. And now if the existing tokens are 20, then the user will end up having 45. Now if you carefully look, I have missed a key detail here. This value here is unbounded. If enough amount of time elapses, then the user will end up with a significantly large number of tokens and this token bucket algorithm basically becomes useless. So have a think about this. Pause the video if you want and let me know in the comment section what do you think we should do. So we should actually have an upper limit or the upper size of the capacity of the bucket. The analogy again goes back to the limited capacity that the bucket has. A bucket can only hold certain amount of coins or a certain amount of water. So in this case, we have something called a bucket capacity. And here, capacity, don't mind the spelling mistakes. And we basically take a minimum of these two. So if the bucket capacity is 50 requests or 50 tokens in this case, sorry, then the user will be able to make 50. But if the new tokens calculated is above 50, then the user still be able to make 50 because that is the minimum or that is the burst capacity of our bucket. So this will make sure that the user over a period of time does not accumulate a large number of tokens and does not abuse the system in the end. Let us look at a sample application for the token bucket algorithm. Nothing fancy here. I'm using Flask for basic web server and API. I'm also using Redis as a cache backend, and I'm like, you can see here there is a Docker container that runs. It's been up for some time, and it is up on 6379 port, and the host is also connected to 6379. So you should be able to connect to Redis, and this is the configuration. So we have a Redis client here. Few defaults: bucket capacity of 10. Again, a lot of thought goes into how we define this. It depends on the system capacity, depends on how much we want to scale, how much we want the user to send traffic, or how much data we are actually expecting to receive. Refill rate 1 tokens per second. Again, this is again determined by the system constraints, load, etc. So this is actually the main method that I will just implement, and we'll get there in a second. But yeah, this is just a sample API which does not do much. It just returns a request and a response, and this is like a middleware or something that calls before the actual request, and it then calls our calculate tokens, which we'll implement now. And if the tokens are greater than 1, then we decrement the tokens, set the actual number of tokens, and basically return void, which means that it goes to the request. If not, we return an error and a 429 request, and we'll see how that comes up. Let me just clear that here. And now, so if you want to think about this method, the parameter that we are passing is actually the bucket data, and it contains the current number of tokens and also the last request timestamp that the user has or the user made the request from. Now, let's first define the current time, and that would be time.time. And since I'm storing this as an integer value, let me also convert this as an integer. Now we need to find out what the current number of tokens are, and in order to do that, we get this value basically from the Redis. So let's do data.get. So dictionary, the key here is again tokens, and the default would be the bucket capacity. So at the first instance, or when the user is accessing a request for the first time, they would not have any tokens that are set in the Redis cache layer. So they would have a default of this bucket capacity, and then it gradually decreases from there as more time passes on. And this again, since Redis stores these as strings, so I would convert them into an integer so that it's easy to do some arithmetic on that. Let's calculate the amount of time that has passed or elapsed. Said that right, time. And that would be the current time minus, again, let me start with the integer, and now I will again get this value, and this is actually last refill here. So let me try that, and the default would be now. So this would be the elapsed time. And now let's see TTR. And if you remember from my previous explanation, that means tokens to refill. That is your refill rate multiplied by your elapsed time, which you calculated previously. And finally, all we have to do is return a minimum of bucket capacity and the sum of current tokens plus the tokens to refill, and that's basically it. We save the file. Now I think I'm running the Python server here, so yeah, it's running now, or it's not, maybe. Yeah, let's start this now. It's up. So I have, I think, a small curl that will just simulate a small load. This is 15 requests, and let's just hit that. So if you see, the first few requests came in, and since the system had enough number of tokens, the request was successful. And the moment the rate of request exceeded the refill rate, the system started denying the request, and we got rate limit exceeded. If you want to see the HTTP error code, let's also do that. So -v in curl gives you a verbose response. So as you see, the last few ones have a rate limit exceeded, and if you see here, we have 429 too many requests, which is the HTTP standard for too many requests. Let us recap. We saw what is rate limiting, we did a walkthrough of the token bucket algorithm and did a basic implementation of a rate limiter using Flask and Redis. In the next episode, we'll scale this out and build an async version of rate limiter using Fast API, which would be able to scale for 1000 requests at ease. If you like to see this video and also want to see more videos like this, hit the like and subscribe button. It will greatly help the channel. As usual, the code will be shared in the GitHub repo, which I'll post down below. Thank you so much for watching and see you in the next one.